All right, guys, so we're going to do more of the stuff we did yesterday today. The difference is going to be, today I'm going to show you how we can do those things using Google Sheets. Now, Google Sheets isn't going to do everything for you. It's not like we just type in the information and it's going to give us that interval. What Google Sheets will allow us to do is find that margin of error. Now, the margin of error was the amount that we added to the point estimate and subtracted from the point estimate. That's what Google Sheets will find for us. So yesterday we used the equation, the z-score, the z sub c, times the quotient of the standard deviation divided by the square root of the sample size. You had to look at the table, you had to find the corresponding z-score, find the standard deviation, find the sample size, plug it in, use your calculator, and you had your margin of error, which you then added and subtracted. When we use Google Sheets, you won't have to worry about the table. Now, you will need to worry about, again, I think in section 3 or 4, we're going to try to find sample sizes using our confidence intervals. So we're going to have to use those percentages again. But for the time being, for the next couple sections, we are going to use Google Sheets to bypass using that formula. And so in order to do that, we're going to use a command called confidence. So equals confidence. Now you'll notice that we have a few different options. We have confidence, confidence T, and confidence norm. Confidence and confidence norm are the same thing. They are finding the margin of error, given that you know the population standard deviation, the level of confidence, and the sample size. The one in the middle here, confidence T, is an interval for students' T distribution. That's what we're going to be doing in the second section. In the second section, we talk about what if you didn't know the population mean and you didn't know the population standard deviation. How could we approximate the known average without knowing either of those values? That's going to involve some degrees of freedom and just working with pure samples. We're not doing that one yet. So it is important that you differentiate between the confidence and confidence norm and the confidence T. So I'm just going to use confidence, and I look at what they're asking for. They want to know alpha, they want to know the standard deviation, and they want to know the population size. Now these two I'm familiar with, but this alpha, not so much. Now in simplest terms, it says down here that alpha is 1 minus the desired confidence level. So if you are 90% confident, alpha will be 10%, because 90% is what you think that you're 90% confident that you're right. That means you're 10% confident that you're wrong. And alpha represents the probability of being wrong. Now, the reason why they're focusing on the negative is because in statistics, we will, especially in next chapter when testing, we want to be able to conclude something based off of the risk of making an error and the probability of being wrong. If that probability is low enough, we'd be willing to make the jump that perhaps we might be right. And there are two types of errors, and one is alpha, the other is beta. Now, alpha is not important right now because we'll be getting into the difference of the two in chapter 9, but just so you know, alpha is the probability of making what we call a type 1 error. Type 1 means that you thought that something was wrong, but in reality, it was just fine. So for instance, let's say you work in a manufacturing plant and you think that the machine that you operate is out of whack, that it needs to be recalibrated. So you shut down the machine, you recalibrate it, and then you find that you actually just wasted your time because the machine was fine the entire time. Now that's a type 1 error. You thought something was wrong when everything was fine. You wasted some time, you wasted some energy, but no harm, no foul. You can continue on with manufacturing. Type 2 is when you think nothing is wrong, and in reality, something is. So with this manufacturing example, you're sitting there, you're working your machine, and it is punching a hole through sheet metal 1/4 of an inch too far to the left. Now you think that everything's fine, so you let it ride. Come to find out, everything that you produce for that entire shift now has to be recalled and thrown out. So you've just wasted time, you've wasted money, you've wasted material. And if that shipment were to go out and go to another plant, Now all those things may be defective. And so you have to have a recall of everything that your parts may have been part of just because you did not check the calibration of your machine. That's a type 2 error. That's more severe. Now, usually the everyday error will be type 1. So that's why we're focusing with alpha, because that's the more common thing that we'd be willing to risk. I am willing to risk a type 1 error that maybe we're overly cautious when we didn't need to be, rather than just throwing caution to the wind and just seeing what happens. So I'm not really willing to gamble with a type 2 error, but I am willing to gamble with a type 1 error. So that's why they're focusing on alpha. We'll be using it again. I'm going to give you the same explanation in a chapter because we'll be focusing on the alpha, which is what we're going to compare a certain value to, and then we can conclude with a certain level of confidence that we think that this might be happening or that might be happening and all that. So that's my background on alpha. Okay, so with the first example on the homework, it was talking about Allen's hummingbirds. So I'm going to use that example, and so we should be getting a range that would be equivalent to the first answer on the homework. So we were using 80% level of confidence, so my alpha would be 20%. The standard deviation of Allen's hummingbirds were 33 hundredths, and the population size was 15. So I am getting my margin of error, which is 0.109, all those digits. So now to come up with my confidence interval, so this was an 80% confidence interval, I'm going to take my point estimate. Now the point estimate was that a hummingbird weighed 3.15 grams. So I'm going to do equals 3.15. I am going to subtract that margin of error, and I get the lower weight of a Allen's hummingbirds. And then I am going to do the same thing, but I'm now going to add my margin of error. And I get that with an 80% level of confidence, I can say that all Allen's hummingbirds will weigh between 3.04 and 3.26 grams. So that's how we're going to use the confidence interval command. Again, 1 minus your level of confidence, so that's alpha, that's the probability that you think that you may be wrong. Your standard deviation, your sample size, once you plug that information in, you want to subtract it from your point estimate and add it to your point estimate. So there's a few problems in Google Classroom, try those out. If you're confused at all, please come into the Zoom and we can figure things out.